Hello, my name is Nathan Terabassi, and my presentation is on black hole evaporation. How black hole evaporation was discovered. Stephen Hawking was probably the main figure in this discovery. He actually found that black holes aren't completely black and they emit a small amount of radiation. That radiation he named Hawking's radiation. And the Hawking's temperature is something that was found in black holes that creates the radiation. The quantum field theory is also a main or a key topic in this discovery, and Stephen Hawking based a lot of his research off of the quantum field theory. How black holes evaporate. Vacuum fluctuations is the key process for a black hole to evaporate. Hawking's radiation says that the black hole loses mass due to the emission of its radiation. And the black hole has to lose more mass than it is gaining from other objects around it for the process of evaporation to commence. How black holes evaporate continue. During the fluctuations, it seems like the law of conservation of energy is just ignored. But the reason that the fluctuations seem to skip a beat is because the particles, antiparticles, and their pairs can be created. So, like we were doing with quarks and antiquarks, it's kind of the same idea, where in that short amount of time, they're creating the antiparticles. Quantum vacuum. The quantum vacuum cannot be perceived or measured directly since it appears to be empty. In fact, it is filled with potentiality. Within the quantum vacuum, pairs of virtual matter and antimatter particles are continually created and destroyed, borrowing their mass and energy by the uncertainty principle. They do not exist as observable entities, but their existence is exerted on other particles as a subtle pressure, which is called the Kashmir effect. The duration of evaporation, it differentiates on the amount of radiation gave off by the black hole, and the smaller amount of radiation gave off, the slower the black hole will dissipate. A black hole with the weight of a car would have and has the diameter of 10 to the negative 24th meters, and it'll take about a nanosecond to evaporate. And what happens after the black hole evaporates? Normally, and the most common result of a black hole evaporation is a gamma ray burst, which is shown in this picture. But there's also some controversy about whether it just completely dissipates if it doesn't create a gamma ray burst. They're not 100% sure on exactly what it does every single time. And some people even say that with the Hawking radiation, he didn't produce enough information because it's all based on theories where they're not certainly proved yet. So he can't really justify his Hawking radiation.